For decades, oil extraction relied on immense physical labor. Extracting energy meant sending crews of workers directly into the elements, standing shoulder to shoulder with heavy iron and highly volatile equipment. Tracking the operation was entirely analog. If you needed to know the pressure inside a pipe, a worker had to physically walk out to the site, brave the environment, and read individual gauges by hand. This created a severe vulnerability, the lag time of human response. Operators almost never caught a problem as it was developing. They only knew a component was failing after it had already snapped. The consequences of those delays were severe. A slow response to a pressure spike could mean massive equipment failures, critical environmental leaks, and forced manual repairs on rigs pounded by offshore storms. As long as the physical infrastructure remained completely disconnected from a central intelligence, those dangers and inefficiencies were permanently built into the industry. To eliminate that dangerous gap in time, OmniPetro developed a completely different approach to infrastructure, the smart field. A smart field turns miles of silent, static pipes into a continuous, living digital ecosystem. The metal is finally waking up. By giving the facility a central nervous system, the network tracks its own physical state, from a massive storage tank down to a single valve in real time. This starts with a massive baseline sensory layer. Every pump and pipeline is wired into the network, continuously transmitting vital signs like internal pressure, temperature shifts, and physical vibrations. Above ground, autonomous drones act as the facility's macro-level eyes, constantly patrolling the sheer physical scale of the acreage from the sky. Looking at this pipeline map, we can see exactly how the drones operate. They run continuous thermal imaging sweeps across the grid, catching a sudden heat spike to expose a hidden internal leak long before it breaches the surface. By layering microscopic vibration data from individual pumps with macro-level heat maps from the sky, the system creates a high-fidelity visibility map, flagging subtle mechanical shifts that would be invisible to a human inspector. All of that raw telemetry floods directly into remote operations, the central brain of the OmniPetro network, built to process the field's data influx from anywhere on the planet. Humans alone cannot process millions of data points per second, so the system uses strict human-machine collaboration to intelligently divide the cognitive workload. This logic flow shows how that delegation works. The system routes the immediate mathematical complexity, like balancing flow rates in milliseconds, to the AI. It only pushes high-level, strategic alerts upward to human experts. The modern operator has evolved from a vulnerable worker recording numbers in a hazard zone to a highly informed decision-maker directing the operation from a global control center. Gathering and analyzing data only matters if the facility can physically act on it. Robotics serve as the new mechanical hands of the operation. Autonomous robotic units now navigate steep catwalks and extreme thermal environments to perform close-up inspections, entirely replacing the need to risk human lives. On a micro level, the infrastructure acts entirely on its own. Smart valves instantly throttle fluid flow and balance internal pressure without a human operator ever clicking a button. This schematic of the pipeline grid illustrates the ultimate goal of the OmniPetro system: self-healing. If sensors detect a critical fault, the system reacts instantly. It clamps down adjacent valves, entirely isolating the hazardous zone to contain the threat. In milliseconds, it recalculates the fluid dynamics and draws a new path. The product is rerouted through secondary pipes to keep the facility running while human crews schedule the repair. By isolating a wound and adapting around it, the oil field behaves like a living organism with a functioning immune system, driving operational downtime down to nearly zero. OmniPetro's automation converts the extraction process into a system that prioritizes risk mitigation and environmental oversight alongside production volume. By catching microleaks before they rupture and constantly optimizing energy usage across the entire grid, the facility sharply reduces physical injuries, lowers atmospheric emissions, and cuts wasted power. Technicians no longer risk physical injury for routine data collection. Instead, they act as strategic controllers who define the operational boundaries and long-term goals for the autonomous network from a safe distance. The surface infrastructure is now mapped, conquered, and running as a predictable ecosystem. But the newest and most complex frontier lies miles beneath the Earth's crust, in pitch-black darkness and crushing pressure. How do you build an autonomous system to map and predict chaotic geological formations that no human eye can ever actually see? Conquering the invisible subsurface is the ultimate test of the network. We'll show you exactly how the AI navigates the deep in our next episode.